Bienvenidos, Ushamdi, and welcome CTS-131, Section 875 students for the Spring 2018 semester at Anne Arundel Community College. This is the Routing and Switching Essentials version 6 course from the Cisco Networking Academy, or the Networking 2 course at AACC. And this afternoon's Packet Tracer tutorial and solution set is going to be on Packet Tracer Activity 3.2.1.8, where we're going to be taking a look at RIP version 2. And RIP is sort of our gateway into dynamic routing protocols. So let's go ahead and take a look at the topology that we're going to be dealing with here. You can see toward the center of the diagram that we have an internet presence here, and we only have a single exit point from our enterprise network. So if I was to draw a line around our internal network, right, this is where we would find all of those RFC 1918 private addresses that are not publicly routable out here on the internet. And so you can just assume, we'll just say that this is company ABC. And company ABC has a Cisco router, and that router is connected to, and let's just go ahead and say this is Verizon, right? Could be Comcast, Cox Cable, whomever. And then we've got this web server out here with the 64.100.0.10, a publicly routable, a non-RFC 1918 address. And so when we look at this, we can see that how many subnets do we have over here behind router 1? So we've got the 192.168.1.0. We have the 192.168.2.0. We've got, and that's a transit network. And remember, it's a transit network because there's no hosts here. Traffic is simply transiting across this network segment. Then we've got the 192.168.3.0, right? And we've got hosts over here. And we've got another transit network segment that's 192.168.4.0. And then we have the LAN over here, 192.168.5.0. So we have 3 LAN segment networks, and we have 2 transit segment networks. And now what's interesting, when you look at these 2 networks here, these are point-to-point connections. But what's interesting about the networks that are being used for these point-to-point connections? Exactly, they're /24s. And remember, a /24 gives me 254 usable IP addresses. Now, a lot of the diagrams that we've seen and the activities that we've done up to this point, what is the CIDR notation? In other words, what is the subnet mask of these transit segments, these point-to-point serial connections? They're typically what? Yeah, they're typically a /30, and that means it's a 255.255.255.252 dotted decimal notation subnet mask, because with a /30, we have a total of 2 usable IP addresses, and we have 4 total addresses, the broadcast address and then the subnet identifier, or the network ID, and then we have the 2 usable IPs in a /30, right? So this is a little interesting that they decided to go with /24s basically across the board. It makes sense on the LAN segments, the 3 LAN segments, but for the transit segments, these could have just as easily been /30s. Now, when we take a look at the activity here, it says, although RIP is rarely used in modern networks, it's useful as a foundation to understand basic network routing, and specifically with dynamic routing protocols. And this is a very true statement. You do not see RIP used very often, if at all, for a whole host of reasons. First and foremost is that it has a hop count max of 16. So once you go beyond that last hop, your traffic is going to drop, right? And so that's one of the major drawbacks with the RIP routing protocol. So let's go ahead and dive in. We're going to configure RIP on router 1. So use the appropriate command to create a default route on router 1 for all internet traffic to the exit network through the serial interface. And so we're basically going to be creating a default static route that is directly connected. We're going to be using the directly connected interface serial 001. So let me clear the screen here. Now, I know a number of you are struggling with the configuration of a static route. And I know this concept is new coming out of the Networking 1 course. And so I'm going to take it slow here. We're going to start in user exec mode. We're going to transition to privilege exec. I'm going to get into global config. And remember, we're creating a static route that just happens to be a default route. And we're doing that on router 1. And what we're saying here is that router 1, and we're going to do this in RIP, you're going to see what happens here, where router 1, my guess is that with RIP, we're going to do a default information originate. Whoops, my pen stopped there. We're going to do a default information originate. And what we're going to do is we're going to propagate the default route via the RIP routing protocol to all of my network routers. And then they will all have default routes that they have learned from RIP. And so this is in contrast to doing it with static routes, because if we wanted to do this with manual static routes, instead of allowing RIP to auto-magically do it, I would have to put a static route, default route here that pointed to that interface. I would need a static default route on router 2 pointing to that interface, and then I'd have to configure a third manual static default route pointing to that interface, right? Because I'm assuming we're doing directly connected here, right? So I would have to go onto 3 different routers and create 3 different default routing statements. Now, when it's 3, you may be thinking to yourself, well, that's not so bad. Maybe I can, that's not a big deal. I'll get a little practice in. What if you have 30 routers? And then it becomes even more complicated, right? It becomes more overhead for you to have to go and touch every single router to make this happen. So this is the entire premise behind dynamic routing protocols like RIP, OSPF, and EIGRP. And what we can do with those routing protocols is I can originate, in other words, advertise a default static route. I only manually configure it one time on router 1 and then give RIP the statement, which is default information originate, and it will give it to all of the other RIP speaking routers. And the same thing can be done in OSPF, and the exact same thing can be done in EIGRP. And when I say the exact same thing, I mean the origination and the advertising of a default route. And it makes sense that we put the default route on router 1 for a couple of reasons. The first reason is that this is the only way out of, if I redraw I'll do it like this, this is the only way out of our network. So it makes sense that we put the default route here and point it out that direction, and then advertise that to these routers. And what that means is that all 3 LAN segments, if they don't have a more specific match, right, on the routers that service these segments, if the routers don't have a more specific match for the destination network in their routing table in the RIB, the routing information database, then they will fall back and use their safety net, which is going to be this default static route. All right. So let's go ahead and let's make this, let's make this happen. I'm trying to give us a little more reading room there. I want to see all the, okay, there we go. So we'll come right up to there. All right, so here we are on router 1. I'm in global config right now. And so the first thing we're being asked to do is to create the default static route. Remember, I only have to create it one time. And after this, RIP is going to be responsible for advertising it. So think of it like this. My route to get to all IPv4 networks for which I don't have a more specific match in my RIB, my routing table, I'm simply going to throw that traffic over the fence out the serial 001 interface. And that's the interface that goes to the internet. So I've just created a directly connected default static route. And then of course, when we use that directly connected, we see that if it's not point-to-point, we may have a performance impact. We can ignore that because this is a point-to-point connection. So that is the default static route. Now, one of the things that's confusing is this syntax. And all this means, if you think about it, what do we typically put in here? Right, if I was creating a default route, let's say that I wanted to create a default route on router 1 that pointed to the network over this LAN segment behind router 3. Well, I would say IP route. In other words, my route to get to the 192.168.5.0, right? The network, and then the subnet mask, 255.255, and my pen is dying out on me, .255.0, a little dot right there, is to go through or out which interface. And if that was the static route that I was creating on this router, it would go, I would throw it out that interface right there. And that would be serial 000. And this is directly connected. To make it fully qualified, I would put the next hop IP address on the same line. And if I wanted to make it a recursive static route, I would simply use the next hop IP. So those are the three ways to do it. And again, think of it like this. My route to get to this network with that subnet mask is out that interface for directly connected, or fully qualified, or if I wanted to do recursive, right? So three different ways that we can approach it. And hopefully that's going to provide some clarity around creating static routes. Now, in this case, we've just created a default because remember, the quad zeros, as they show up right there, match every IPv4 network, right? So if I don't have a more specific route in my routing table, that is my catch-all. That is the fallback right there, is that all traffic I don't have a more specific match for, I'm simply throwing it out the serial 001 interface. All right, now we're going to enter RIP protocol configuration mode. So to do that, I simply say router RIP, and that's it. We're going to use version 2. You always want to use version 2. You always want to use version 2. And the reason that you want to use RIP version 2 is RIP version 1 is deprecated and it is classful. And what that means is RIP version 1 doesn't understand subnetting. It looks at everything as being classful, right? So a 172.16.1.0/24, RIP version 1 says, oh, it's 172.16.0.0. It treats it as a class B no matter what, right? And you don't want that. And disable automatic summarization. So we say no auto summary. And the reason that we do this is we don't want RIP to automatically summarize things to their classful boundary. All right, we're going to configure RIP on the networks that connect to router 1. Now, this is an interesting proposition here. And this is going to introduce the passive interface command. And we'll come across this, and you'll see Packet Tracer sometimes will not give you points unless you put it on the internet-facing link, like with OSPF. I think there's one I've run into that does that. But the bottom line is we would not, again, I repeat, we would not run RIP on that network interface. And the reason for that is we are not running the RIP routing protocol with the service provider. You don't do that, right? You simply do not run RIP with the service provider, because if you did that, the service provider is now learning all of your routing information. That is a major security hole, right? You don't do that. That's why we have the default static route that just basically says, if I'm not going to a network here that I'm going to know about, then throw it out to the internet. And that's okay, right? But we wouldn't set up a RIP adjacency, a RIP routing adjacency with an internet service provider. You would not do that. And you wouldn't do it with OSPF or EIGRP, right? Now, the protocol that you would use we'll be discussing in the fourth and final CCNA course at AACC, which is the Connecting Networks course, or Networking 4. And that is the Border Gateway Protocol, or BGP, but that's outside our scope here, right? So we're easing our way into dynamic routing protocol. So I turn auto summary off. Now it says configure RIP for the networks that connect to R1. So there's two networks that connect to R1. It's this network here and this network here. Again, we would not do it on the internet-facing interface. In fact, we're going to passive that interface. So how do I get my network statements in here? I say 192.168.1.0, and then I say 192.168.2.0, right? Those are the two LAN networks, right? Not a WAN, wide area network connection out to the internet. Now, I'm going to be curious to see if we get... and I'm sorry, I was saying pass about the wrong thing. I was checking to see if we get points for passive on the gig interface, which is, I think it's gig 0. It should be gig 00. Do show IP interface brief. And it is. All right, passive interface, gigabit Ethernet 00. Now, this command is one of those commands that tends to cause some confusion. What this is not doing, right? Let me say what this is not doing. When I put the passive interface gig 00, right, and that's the gig 00 interface right there, what this command is not doing is it is not preventing that network, the 192.168.1.0, it's not preventing that network from being advertised. What it's preventing is it's preventing RIP multicast messages that are going to get fired out here, out this interface. It's preventing RIP from sending messages, RIP messages, in search of other RIP-speaking neighbors out the LAN interface. And the reason that you passive the gig 00 interface here is you have to ask yourself this simple question. Out here, out this interface, is there any other router or node speaking RIP? Am I creating a RIP routing adjacency with switch 1 or with PC 1? If the answer to your question is no, then you passive that interface. And the same is true here. You can assume that we're going to be passiving that interface, and we're going to be passiving this interface for the single reason that there are no RIP-speaking routers out here. So there's no reason for the messages to be sent out those interfaces. In fact, it is a huge security threat and concern if you allow RIP to send those messages out here, because if this guy here is a bad actor on the PC right here, and he says, oh, hey, I figured out how to get Wireshark on the PC, and then he starts sniffing the traffic in his broadcast domain and happens to start seeing all of your RIP information, he may then try to insert himself into the RIP routing domain and pretend to be a router. And then what happens when he advertises a default route out here, right? Or starts sending bogus routing information out? Then you've got a situation. So that's why we passive those interfaces. Let me go ahead and clear that. Okay, so we're back. And we passive the gig 01 interface. I'm sorry, I think I initially said we would passive this. You don't passive that interface. You just don't run RIP on that interface at all. All right, now, last but not least, configure the LAN port that contains no router so that it does not send any routing information. We did that with a passive interface. Advertise the default route configured in step 1. So how do we advertise the default route? What do you think? Is it redistribute? No, it's not redistribute. It's default information, and then it's originate. Now, That's the command that's going to advertise the default static route that's on router 1 into the RIP routing protocol, right? So now we're going to end. I'm going to say write mem here, save my configuration, and we're going to scoot up. And actually, I think we're already at the bottom. We are. So now we're going to configure RIP on router 2. So I'm going to pull this over here, and we're going to get out of the way so we can see what it is we're doing. And you'll notice on router 1, I only configured the networks to which router 1 is directly connected, to which router 1 knows about, right? That's why on router 1, I didn't configure a network statement for the 192.168.3 or the 192.168.4 or the 192.168.5 because router 1 is not the keeper of those networks, right? So here we are in user exec. We'll go to privilege exec, and then in the global config, we're going to go router RIP. We're going to scoot along here. It's version 2, right? No auto summary. And what is it asking for anything else? And then configure RIP on the directly connected networks. So for router 3, for router 2, we have 3 network statements. It's going to be the directly connected point-to-point link, 192.168.2.0, 2.0, and then 3.0, which is my LAN segment, and then 4.0, which is the other directly connected segment. Now, if you're looking at this and saying, wait a second, Travis, I'm confused. Why on router 1 did you enable that interface? And then why did you enable it on router 2? Don't we just need it on one of the interfaces here? And the answer is no, it needs to be on both because remember, when I enable it by introducing the network command, what that does on the interface is it immediately starts sending out RIP multicast messages, those messages that we don't want out on the LAN segments. And so it sends those messages out, and that is how they learn about each other and exchange RIP messages. And then router 1 is going to be sending messages over to router 2 saying, hey, I know about this network. And router 2 is going to be sending messages over to router 1 saying, hey, I know about this network and this network. Now, the reason I didn't put this in here is they both know about that, right? And it'll be in the advertisement, but more importantly, it's advertising networks that the other router doesn't yet know about. And this is how the router will learn that information. And again, I make the configuration in one spot in the RIP global config section, and then it auto-magically is propagated throughout my environment, right? And this is much better than having to go to all 3 of these routers and start to create manual static routes to all the networks I want to get to. So the last thing that we're going to do is we are going to do what? And it is right there. It says configure the interface that contains no routers so that it does not send out routing information. And let's say do show IP interface brief and make sure it's gig 00. It is. So we say passive interface gigabit Ethernet 00. And so we're scooting along. It looks like we're getting, 75? So I'm assuming there's going to be 25 points here for router 3. So now we've got the RIP process set up. So I'm going to say do show IP route right here on router 2. And take a look what we have learned via the RIP routing protocol. That's what the R stands for as in the legend. And then the asterisk, it says it's a candidate to be a default route. The administrative distance for RIP is 120. Here is a RIP static route. I'm sorry, correction. Here is a RIP route that we have, we've advertised with the network statement on router 1, and this is how router 2 learned about it. And you can see right here via 2.1, via router 1. Right? Because if I come back over here to router 1 and I say show IP interface brief, that's what that via statement is. Here's the IP address on the serial interface between router 1 and router 2. And router 2 says, hey, I have learned via RIP about this network with that administrative distance, and that's the hop count or the metric to get there via that next hop IP That's how long I've known about it, 4 seconds, or how long it's been in my RIB, my routing table. And I would go out my serial 000 interface in order to get there. And this is how dynamic routing protocols work. So we've got that taken care of. Let's say end. And from router 2, what if I ping, and actually we'll hold off on that. Let's go to PC2. So from PC2, if I wanted to ping PC1, and I'm going to assume, did we have an addressing table here? I don't think we had an addressing table. No, no addressing table. So I'm going to assume PC1 is .10, 1.10, okay. So we're going to say ping 192.168.1.10. So does 192.168.3.10, which is this PC, know how to get over to that network? And it does. And it knows that because it has a default gateway entry that's configured on the PC, which is right here. And it says, if I'm trying to go to a network that I don't have in my network table, and really PC2 only knows about this network, 192.168.3.0/24. So if PC2 wants to go to a network that it does not have a network statement for, it will send that traffic to its default gateway. And 3.1 is router 2. So then the traffic shows up here on router 2, and router 2 says, hey, PC2, thank you so much. I'm your default gateway. Let me take a look at the destination network that you're trying to go to. And that's where router 2 looks into its routing table and says, you're trying to go to 1.10, which is PC1. I'm going to look in my routing table and I'm going to see what? Hey, you know what? PC2, I just happen to have a network statement in my RIB that tells me how to get over to that network. In fact, all I know that I'm supposed to do is I send the traffic over to that next hop IP out that interface on me. And that's what router 2 does. And he ships it over here to router 1. And then router 1 looks at the destination IP address. And router 1 says, hey, router 2, thank you so much for sending me that information. And it just so happens that I am actually directly connected to that destination network that you're trying to get to. And then router 1 says, and I know that I send it out the gig 00 interface, so router 1 may ARP to find out, hey, I'm trying to get to 192.168.1.10. Does anybody know the MAC address? Maybe the MAC isn't known for whatever reason. Or it just sends the traffic out the gig 00 interface, and the layer 2 switch gets it, and it knows the MAC address associated with PC1, and then that is how the traffic gets over there, right? So we've configured router 2. Now let's go ahead and configure router 3 to complete not just the activity, but to complete, and actually I'll pull it down this way here, to complete our RIP configuration. So we're in user exec as evidenced by the greater than sign. We type enable or en to get to privilege exec, configure terminal or conf t to get into global config. We're going to say router RIP. We're going to say version 2. We're going to say no auto summary. I'm going a little quicker here. And configure the directly attached RIP network. So I need a network statement for the 192.168.4.0 and then the 5.0. Because again, I only enter network statements in for networks I know about, right? That I am connected to. And the reason you do that is you don't want router 3 doing something like this, right? If I did that, that's misleading because now router 2 is going to be receiving 2 routes for the 192.168.1.0 in RIP, right? We don't want that. You only want to advertise networks that you being the router, are connected to or aware of, right? You want to make sure that you're not pretending like, oh, I know how to get to the 10.5.6.0/24 if you don't actually have a link to get to that network. So that's why we limit the RIP configuration to the router or to the routes that we know about, to the networks we know about. And then we're going to passive interface, and I should probably check this. I believe it's probably do show IP interface brief. It's probably gig 00. It is. So we say passive interface gig 00. Again, I don't want those RIP multicast messages coming out onto the LAN segment. that causes problems for me from a security perspective. And then we're going to save the configuration. So we're going to say write mem, right? So on router 3, and let's give ourselves some more room with which to work here. When I say show IP route, take a look at all of the information I'm learning via the RIP routing protocol. I'm learning about the 192.168.1.2.3, right? And .4, I'm sorry, not .4, 192.168.1.2 and .3. The .4 is directly connected. Sorry about that, went too far. And more importantly, I've got this default route here. Now, you'll notice, look at the default route. Does it say, oh yeah, via router 1? Is this router 1's IP? No, it's not. Because again, it's possible that 3 doesn't know about router 1. So it's a step-by-step process. Because who informed router 3 that, hey, here's the default route? Who was it that told router 3 about the default route? It's router 2. So in other words, router 1 told router 2 about the default route, and router 2 told router 3 about the default route. And what I've just described right there in what probably seems like a comical explanation is the entire underpinning of what a distance vector routing protocol does and how it behaves. Is that router 2 only knows what router 3 told him and what router 1 told him. And the same is true for router 3. Router 3 only knows what router 2 told him. He has no concept of router 1. Again, when I say no concept, he has no idea that router 1 is actually out there somewhere. He has to put his faith in router 2, that what router 2 is telling him, because look at the via. Via who? Every piece of RIP information that router 3 knows about, who is he getting it from? He's getting it from router 2 and router 2 only. And that is distance vector routing protocols in a nutshell. It's commonly referred to as routing by rumor. Is that you're only as good as a router, you're only as good as I'm sorry, let me correct that statement. So let me say it like this. As a router using a dynamic routing protocol that is a distance vector routing protocol like RIP or like EIGRP, you are only as good as the information you're getting from your next hop router. And this is very different from OSPF, which we will be touching on in this course. So remember that distance vector routing protocols are referred to as routing by rumor because I have to trust what the next hop is telling me, because I don't have any clue what's going on beyond that next hop. And that's evidenced here in the RIB, and you can see it right here, via, right? I have to go to router 2 because that is who I'm learning all of this information from. I have no concept and no idea that 2 learned it from 1. I just know what 2 is telling me. And there's your routing by rumor. And that is distance vector routing protocol behavior in a nutshell. Putting your trust as a router in the next hop distance vector routing protocol router. All right. Well, that is going to wrap up packet tracer activity. Oh, wait, I'm sorry. Before we wrap that up, let's test connectivity. How about we test connectivity to make sure everything is working? So on the desktop here, can I ping 64.100.0.10? And this should work because PC3 looks into its network table. It says, yo, I don't know about the 64.100.0.10. I have no clue about that network segment or that IP. So I throw it to my default gateway. Who's router 3? Router 3 looks in its RIB. Do you see something in here for the 64.100.0 network? No. So since router 3 has no more specific, longer match for that network, he falls back to his default route, which says, yeah, just send it over to router 2. Again, 3 has no clue that ultimately this is going to make it to 1 and that 1's going to ship it out for him. 3 only knows about the next hop router. So then that traffic comes here with a destination network of 64.100.0. And router 2 looks into his RIB and says, yeah, I don't have a more specific route. I don't have something specific for that network, but what I do have is a default route. Whoops, and we unfortunately timed out there. We have a default route. And look at all of the RIP information that router 2 knows about. Who is he learning it from? Right? And actually, we need to rerun this because show IP route. There should be information in here from router 3, which is 4.1. So, but the default gateway, who am I learning that from? I'm learning it from router 1. So then router 2 says, hey, router 3, thank you for the traffic that's destined to the 64.100.0. I don't know how to get there specifically, but I do have a default route that's my catch-all. I'm going to throw it over to router 1 because that's what I'm instructed to do here in my routing table. That traffic gets here to router 1. And let's rerun the command, show IP route. Whoops, show IP route. And router 1 looks into its routing table and says, do I have a specific match to get to, something specific here, to get to the 64.100.0 network? And router 1 says, I don't, but I have this catch-all, the safety net, which says that if I don't have a longer, more specific match to get to the network, the destination network that I am routing the traffic for, that I simply throw it out the default route, throw it to the default route, which tells me send it out to serial 001, which is the internet, and the internet will take care of it. And in fact, if I was to say trace route to the 64.100.0.10, let's take a look. Where does it go? So the first thing it does is it goes to, oh, and I'm sorry, that threw me. I thought I was on the router, and I'm like, wait a minute, why is it going to the 5.1? I'm on the PC here. I'm on PC 3, which is, we can't see it. It's on the LAN segment behind 3. So I go to my default gateway, which is 5.1, that interface right there. And then router 3 says, okay, go to the 4.2, which is, if we pull this up and I were to say do show, sorry, let's pull this back, do show IP interface brief, show IP interface brief, sorry about that. The 4.2 is not me, it's the next hop. 4.2 is that interface right there on router 2. So then it goes to router 2's interface. Then it goes to router 1's interface from router 2. Then it goes out to the internet, right? And there's, you know, this cloud here. The service provider is 209.165.200.226. And, excuse me, then it makes it to its destination, right? And that is going to conclude Packet Tracer Activity 3.2.1.8, where we did a deep dive on the RIP routing protocol and how we would propagate a default static route. And it is critical that you understand this concept because this concept does not go away. In fact, we're going to do it in OSPF. We'll do it in EIGRP. You can do it in BGP, right? So this is a very, very common approach in enterprise networks to routing traffic when you're using dynamic routing protocols. All right, guys, thanks for watching. Have a great weekend, and I will talk with you soon.